Okay, so it's been a while since I've actually posted a video. So um I guess sorry about that, but I'll try and post videos more regularly, I guess. So in this video, what we'll be talking about is the cosine rule. But before I get into questions, I might do some questions pertaining to the cosine rule in another video, in which I'll show you different ways in which you could actually apply the cosine rule to CXC past paper questions. So in this video, I'm just going to show you how they came up with the cosine rule. So the cosine rule is basically on the CXC. It's on the CXC paper where they have the formulas. So you don't really necessarily have to know it, but to just know how to apply it. But nothing is wrong with knowing what the cosine rule actually is. So the cosine rule is actually a squared equal to b squared plus c squared minus 2bc cos of a. So while we're going through the video, you understand that these common letters actually represent lengths and the capital letter represent angle. So we have a squared here, as in common a squared, and we have capital A here. So that means we're going to find the side, which is A, and with its respective angle of A, capital A. So let's say we had a non-right angle triangle, and I'm going to label this non-right angle triangle. So we're going to have I'm going to label each vertices. So I'm going to have A, B, C. I'm also going to draw a line from B, which is perpendicular to the length AC, and I'm going to it's perpendicular to AC, so that means right here we're going to have two right angles right here. So I'm going to call this perpendicular height, I'm going to refer to it as H. So that's my height. Not really a pretty H, but yeah. So this is my perpendicular height is considered to be A. So as I said, H. So as I said before, each vertices is labeled as A, B, C. The angle right here, I would call it capital A. The angle right here, I'd call it capital B. Angle right here, I would consider it to be capital C. Now across from A, I'm going to have common A. Across from C, I'm going to have common C. And across from B, which is right here, I'm going to just draw a line like this. So AC is considered to be common B. So what I'm going to do, I'm going to separate my triangle. So as you can see, we have two right angle triangles, so I'm going to separate them. So I'm going to have one on this side, right angle triangle. It's not going to be a very pretty drawing, just going to see if I can finish the video. Just hope students understand what's going on. So we're going to call this side C, this is H. Remember, you can always post questions in the comment section on the video. That is C, this is B, this is H, here is A. Now, as you can see, what I did, I separated the triangle, so that means I cannot label this side as H, we cannot label this side as H, as B, sorry. This side as B, this side as B. Because right now we're unsure of the ratio in which we divided this line AC. So I cannot really call it half B here, or cannot call here half B either, because as I said before, we're unsure of what we divided or the ratio in which we split this line, this length AC into. So what I'm going to do to determine the length from A to the base of the right angle right here, I'm going to apply because we're trying to figure out what the length here is, trying to figure out this length. So I'm going to use SOHCAHTOA. So students should know what SOHCAHTOA is. So SOH CAH TOA. So this is how we actually know what the trig ratios are. So we know that SO is for sine of an angle, let's call that angle theta, is equal to opposite over hypotenuse. So O is for opposite side of the triangle, H is for the hypotenuse. CA is for cos of an angle theta, which is equal to adjacent over hypotenuse. So you have to basically know the right angle triangle. This, which is the TOA section, which is usually used for the angle of elevation and depression, is tan of theta equal to the opposite side of the triangle over its adjacent side. So right here you can see that we're referring to this angle as A. So this side would be the adjacent side. The side that is closest to this angle here is called the adjacent side. When we look from that angle, this side here is the opposite, and when we look through the right angle, this is the hypotenuse. So we're looking for the adjacent side and we have the hypotenuse. So don't let the letters mix you up. Usually they use H for the hypotenuse. So in this case I'm just using C. So this H here is only representing the perpendicular height of our triangle ABC right here. So we're going to use cos. So it's cos of A, which is equal to, as I said before, the adjacent side, which is here. I'm going to call it the adjacent side here, A, over the hypotenuse. The hypotenuse here is C, so don't mix up this H with the hypotenuse. So it's C here, C. So remember, we want to figure out what the adjacent side is. So I'm going to just cross multiply this denominator C. So I'm going to have C cos A, which is the length for the adjacent side of our triangle here. The video looks a bit blurry. Camera needs to focus. Alright, so hopefully you can see this, you understand what's going on. Let's get a bit focused. Alright, so now dealing with this triangle now. So what I'm going to do, I'm going to apply the same principle to this triangle, but it's going to be a little bit different. So we're also looking for the adjacent side. So what I'm going to do, we're also working with the adjacent side. So what I'm going to do, we need to find this length right here, this length. Now if we had the length AC to be B and we found this section of it, what we could actually do is, remember the total length was B, we found this length here, which is C cos A. So basically we could simply determine what this side is, or what this length is. This length would actually be the total length, which was B, minus the side that we have found, which is, so minus C cos A. So this would be the length for this side of our triangle. Now next, what I'm going to do, I'm going to apply Pythagoras theorem to both triangles. So remember, Pythagoras theorem states that I'm going to use h squared equal to a squared plus o squared. So I'm going to apply the Pythagoras theorem formula to both triangles. So h represents the hypotenuse. In this case it is c. So let me just rewrite the formula here, the Pythagoras theorem formula. So h squared is equal to a squared plus o squared. So in this case h would be c, so I'm going to have c, as in the hypotenuse is c, so I'm going to have c squared equal to the adjacent side squared. Now adjacent side, we got c cos a, so it's c cos a all squared plus the opposite side squared, which is h. Remember, we use h for the opposite side, so which is h squared. Now for this triangle, now we're going to apply Pythagoras theorem also. Let me just draw a little dotted line here to not mix up both sides. So I'm going to have the hypotenuse here would be a, so we're going to have a squared equal to the adjacent side, which was b minus c cos A. So it's b minus c, common c, cos A all squared, plus what we are missing, the opposite side. Now the opposite side here would be h as well, which is h squared. Now what I'm going to do, I'm going to simplify both equations. So let's see what we're going to have. We're going to have c squared equal to, this represents, this is basically AC. So if we have right here, we have c cos A. So if we have, let me see, let's put it here. So if I have a b all squared, what I could do, this is the law of indices. I also have a video up on the law of indices. You could probably go and watch that video to better understand what I'm going to do here. So what we could do, we could square the a. I'm going to have a squared. I'm also going to square the b. I'm going to have b squared. So squaring c cos A, I'm going to have c squared cos squared A plus h squared. So this side is simplified. Now with this one, I'm going to simplify this side as well. So what I'm applying here, I'll get a fresh sheet of paper to show you what I'm doing here. So for this section here, I'm going to have a squared equal to, now right here we have a binomial actually, which is a, let's consider it this, for example, a plus b all squared. We have a shortcut to expand this binomial. So we could use the usual way in which we write the product of two binomials, which is a plus b multiplied by a plus b, and we could just simply simplify it and expand and then simplify. But we have a shortcut for this. We could actually square the first term inside the bracket, and we square the last term. So I'm going to leave a space, because when we have the a binomial squared, we're supposed to have three terms, 1, 2, 3 for the final answer. So there's a plus inside, so I'm just going to put plus on both sides. So I'm going to square the a, we have a squared. I'm going to square the b, put it at the end here, b squared, and I'm going to multiply the variables inside the bracket times the power. So a times b, which is ab times 2, is actually 2ab. So this is the principle that I'm going to apply to this, so that this video isn't drawn out. So what I'm going to do, I'm going to square the b. So I'm going to have b squared. I'm going to square the minus c cos A. So what I'm going to have c squared, which is positive, because when you square a negative number, we get a positive number, cos squared A. Now for the middle term, I'm going to multiply. So I'm going to have b multiplied by minus c cos A multiplied by 2. So you realize I'm going to be ending up with minus 2bc cos A. Now remember, we have this here, so don't leave it out, plus h squared. Alright, so what I'm going to do, if you realize we have two equations, I'm going to substitute one of these equations into the other. So I could label this as equation 1, this as equation 2. So I have videos up also on simultaneous equations, because that is what we're applying here. So what I'm going to do, if you realize the cosine rule doesn't have an h or an h squared, so what I'm going to do, I'm going to substitute for h squared. But before, I'm going to just make it a bit simpler. So I'm going to make h the subject. So I'm going to bring over the c squared cos A over this side. So you realize that I'm going to have h squared equal to c squared. This is positive. When it goes over the equal sign, it's going to be negative. So it's c squared minus c squared cos squared A. So this is what h squared is. Now we could refer to this as the third equation. As I said before, I have videos up and with simultaneous equations. So what you could do, you could go ahead and watch and have it on both methods. I think I have it videos up on substitution and also elimination. So what I'm going to do, I'm going to substitute for h squared. So I'm going to substitute for h squared. So anywhere I have h squared in this equation 2, I'm going to substitute what h squared is. for equation 3. So I'm going to rewrite everything down here. So I'm going to rewrite all of this, but instead I'm going to substitute for h squared. So I'm going to have a squared equal to b squared, which is this, minus 2bc cos A plus plus c squared cos squared A plus, remember right here we should have had h squared, but what is h squared? H squared is c squared minus c squared cos squared A. So what we could do, we could collect like terms. So these are like terms. I'm just going to underline the like terms. So they're going to cancel each other because we realize this one is positive, this one is negative. So they're going to cancel each other. So what we're actually left with is a squared equal to b squared. I'm going to move this positive c squared here. So I'm going to have b squared plus c squared minus 2bc cos of A. So this is how they came up with the cosine rule. So sorry for the untidy writing, because I don't know, this is not really a perfect handwriting from me. So hope you have enjoyed the video, and if you have any questions you can also, as I said, ask it in the comment section. I'll get to you as soon as possible. So thanks for watching this video, and remember, if you're not a subscriber, you can always subscribe to it. Yeah, also if you have any questions you can also type it in the comment section, and I'll also answer that question for you as soon as I see that question.